Hello YouTube, this is Umoso3. In the previous lesson, we learned about a new type of data structure called a queue, right? And so we've been talking about new data structures called linked lists and stacks and queues. And so we're trying to understand what these data structures look like conceptually, right? And so first we talked about array lists. And we said basically it's a resizable implementation of an array where we can add or remove elements, right? And elements would occupy particular index positions. And then we talked about linked lists, and we said linked lists have the same functionality, but they're better at inserting and removing elements and not as good at accessing or manipulating elements at particular index positions, right? And so linked lists are more defined by having nodes that are connected to one another rather than elements that are occupying specific index positions. And then we talked about iterators, and we said basically that we can create an iterator object on an array list or linked list, and basically this gives us a straightforward way to iterate through an array list or linked list, basically to print the values within it, right? And then we said in the previous video that you can actually have an iterator for a stack or a queue. So these are two new data structures that we're learning about, stacks and queues. And basically what we said for stacks is you can think about like a stack of dinner plates, right? Where essentially the last items that are coming into the stack are the first ones out of the stack, right? The plates that you added most recently are the plates that are going to be removed the quickest, right? And the difference with a queue is the opposite. So queues are first in, first out. So instead for a queue, you would want to think about a line at a supermarket where the people who are coming into the line first are the people who are going to be served first, right? Like that's the opposite of a stack, right? And a stack would be a much less equitable system, right? What if you came into the line first, but then you had to wait the longest to be served? That wouldn't make a lot of sense, but that would be a stack. But anyway, what we had in the previous video, we were just reviewing a lot of things and we ran out of time. So what I want to do is review what we had. Remember, we had different static methods. And so one static method was responsible for creating a linked list, right? And we said in order to create a linked list, you have to import java.util.HashSet at the top of the class. But this would create an empty linked list, and then it would create 10 egg objects, and it would add those 10 egg objects to the linked list and return the linked list. And we said we can have a sorted version of a linked list or an array list by saying collections.sort of array list or linked list, right? And then you could just go ahead and use a for each loop to go ahead and print the elements in the linked list or array list. And then you can have the minimum or maximum value by saying collections.min of my list and collections.max of my list. And that can be defined for any class, for any data type, as long as it has a compare to method, right? As long as it implements the comparable interface and defines the operation of less than and greater than. And then we also have an iterate through method where we basically tested to make sure that we knew how to use an iterator. And so we said we could create an iterator object based on an array list or linked list, right? We use this iterator instance method and you call it on your array list or linked list, and it returns an iterator object where if you call hasNext or next on that iterator object, then these sorts of methods allow you to basically iterate through the array list or linked list and print the elements within it. And then you can also go ahead and generate a stack. And so we said with a stack, we're going to have last in, first out. And so in order to add elements to a stack, first you have to import java.util.stack at the top of your file, and then you create a stack object. So you would say stack of type egg, stack1 equals new stack of type egg, or stack of type string, stack of words equals new stack of type string. But whatever you want to do, it has to be an object, right? Not a primitive. It can be an integer, but not an int. It can be a Boolean with a capital B, but not a Boolean with a lowercase b. But we're going to go ahead and push those 10 egg objects onto the stack and then return the stack, right? And then we can show the stack after the push, and we can go ahead and make sure that after pushing the egg onto the stack, then it would appear when we go ahead and iterate through the stack. So we would want to see that element added onto the stack, right? And then we can also show stack after peaking, right? So we said that peak shows the top of the stack without removing it from the stack, right? And so then we could create another iterator object and just make sure that just because we looked at the top of the stack doesn't mean that it fell off of the stack, right? So really it should be printed twice, first for calling peak and then second because we called next and it wasn't removed, right? But pop would remove it. So if you call my stack.pop, then that element that you're removing, it's only going to show up once, right? It's going to show up once as you're removing it, but not when you iterate through the stack after having removed that element. So hopefully that makes sense to you. And then also the search method, right? So search would return 1 for the top of the stack, 2 for just below that, 3 for below that, and so on. But you could pass in the stack and the egg that you're searching for, and then it would return that operation. And then also queues, remember, so a queue is first in, first out. So we can go ahead and generate a queue, but instead of calling .push, you would call .add. So q1.add a v1, q1.add a v2 for those 10 egg objects, and then return q1. And then you could say public static void show queue after add. What if you wanted to add an egg onto an existing queue? So you'd have to pass in the existing queue and the egg that you want to add to it. And then you would basically say egg to add to queue, and then the string representation of that egg object. And then you would call myQ.add of new egg, right? And then you could create another iterator object and make sure that the new egg appears, you know, as you iterate through the queue. Okay, and then you could show queue after peak. So what if you just want to look at the front of the queue? What if you just want to look at who's in line who's first in line at the supermarket without serving them, right? And so that's you would use myQ.peak, right? And then when you create the iterator object, hopefully it would still appear in your queue, right? But with poll for queue is kind of like pop for stack. So with poll, you would return the head of the queue, you would return the first element in the queue and serve them, right? So then when you iterate through, hopefully you would no longer see it appearing at the front of the queue because you already removed it. Okay, and then we have this main method, and I just wanted to demonstrate this to you, and then hopefully we'll have enough time to talk about new content in this video. But what we're going to do is run the main method, and then I'm just going to go ahead and show the terminal window here. So again, we kind of ran out of time in the last video, but we have an original linked list, right, where we have this egg has a resolution of 43, right? These are just the resolve values, the result of A minus B for the 2 integer inputs that we passed in for each of these instances, right? So 43 was the first one, right? Because then if we go ahead and look at the code when this finally loads, I don't know why that's taking so long, but the first resolve method would have returned 43, right? We had 45 minus 2, and that gives 43, right? But then we have a sorted linked list as a result of doing collections.sort of linked lists, right? And we have the minimum and maximum elements. And then we applied the iterator object, and we get the same result as if we had just used a for each loop, right? And then we can print an initial stack, right? And then we can basically push a 555, push an egg with a resolve value of 555 onto the stack. And so that's why it appears in the stack now. And then we can go ahead and look at the peak of the originally generated stack, which was a 2. That's what the top element was of the originally generated stack, was a 2. But then if we pop off the 2, then we don't see the 2, right? Then the top of the stack will be a 17 if we call pop, because pop removes the top of the stack in addition to returning it, right? If we print an initial queue, now we're talking about printing a queue, right? So if we add an element with a resolution of 888, then it would appear here, right? It would appear basically at the end of the line, right? But then if we're going to peek at the front of the queue, now what we would be looking at is looking at the front. So now we would be looking at the 43 and not the 2 as we were looking at with the stack, because now we want to serve the first customer, right? The first person that came into the queue is the one that would be returned by peak, right? But peak doesn't remove the 43. So that's why you still see the 43 being printed here. But if you pull the 43, so if you say, let's pull the front of the originally generated queue, then you would be removing the 43 in addition to returning it. And that's why you don't see the 43 when we go ahead and iterate through the queue after having called pull. So hopefully that makes sense to you. What we're going to do in this video is we're going to talk about sets. Okay, so there's another type of data structure that we can talk about in this video. And then in the next video, there's going to be one more called a map or a dictionary. But what we're going to do is talk about sets in this video. So you might already have sort of an intuitive understanding of a set, right? If you've taken a math class or a computer programming class before, it's a very general word, right? And there's an abstract data type, which is probably what you want to be looking at. So a set is an abstract data type that can store unique values without any particular order. It is a computer implementation of the mathematical concept of a finite set. Okay, and so basically a set is basically a collection of elements where no duplicates are allowed. Okay, so if you have 8, 8, 8, 8, 7, then basically your set would be characterized as having 8 and having 7. Okay, but it doesn't matter that you have duplicates because sets only have unique elements, right? And so this is something that shows up in mathematics too, and a lot of mathematicians will talk about set theory, right? And how do you combine two sets, or how do you figure out the elements that belong to both sets, or at least one of two sets, or how do you figure out the elements that belong in one set and not another? But what we want to do is we want to understand a data structure in Java called HashSet. And so this is another type of class, right? We've talked about a lot of important classes in Java, right? String and scanner and thread and Boolean and HashSet now is what we're going to talk about. So we're going to talk about a set where basically sets can only have unique elements, okay? No duplicates. And we're going to look at different methods, different things that you can do with a set. So when we talk about an array list, you can add elements, right? And you can add duplicate elements, and it's no problem. If you have an array list of string objects, you could have the word basketball 126 times in your array list if you want. But with sets, you could have either 0 basketballs or 1 basketball. You either have a particular unique element or not. And so this is the functionality of sets that we're going to be studying. So we're going to figure out how to add an element to a set, how to clear all elements from a set, how to see whether a set contains an element, how to determine whether or not a set is empty, how to remove an element from a set if it exists, and how to determine the size of a set, okay? And one of the things we'll also learn is that you can also iterate through a set, okay? Because one of the things we'll learn is that you can go ahead and print all the elements in the set, okay? So hopefully that's clear to you. But what we're gonna be doing is we wanna go ahead and create a main method here. So what I'm going to do is I'm going to clear the main method that I had earlier. So we were doing lots of practices with the queues and the stacks, and so hopefully that's clear to you what we were working on. But what we're going to do is we want to go ahead, the first thing that we need to do, so I guess the procedure, so the goal is to implement a set in Java. Okay, so the first thing that we need to do is we need to say import java.util.HashSet. Okay, and so that's the line of code that you need to write at the top of the file. So you'd say import java.util.HashSet, and basically what this would enable you to do is to create a hash set. So you can create a particular set. Okay, and then you could go ahead and look at the constructors. So remember, a constructor is a particular type of method that's responsible for creating an instance of a class. And you can see with this constructor that you don't need to pass in any inputs into it, right? You don't need to worry about any inputs. But what it would do is it would have a particular data type associated with it. So a set is going to be a collection of elements. But what type of element do you want to have? Do you want to have string objects? Do you want to have person objects? Do you want to have egg objects? Do you want to have Boolean objects with a capital B, right? But it has to be a set of a particular object type. Okay, so just like with linked lists and array lists, it would have a particular type associated with it. Okay, so those are the first two steps. So what we would do, let's do a set of words. So we would do set, so we could say unique words, okay, equals new set of type string. Okay, so this is basically how you would create a new set. And so you would call it hash set. So hash set. So hash set of type string called unique words equals new hash set of type strings. And then what we want to do is we want to study the operation. So the first thing that we can do is check to see whether or not the set is empty. So what I'm trying to say is that just like with array lists and linked lists, a hash and stacks and queues, actually, a hash set will start empty. So what we can do is we can go ahead and run the main method, okay, of the queue practice. And then what we would do, the terminal window sometimes escapes me, but what we could do is we would just get true, right? And so the point is that sets will start empty. So basically sets start empty if you call the default constructor, right? Here we have empty parentheses when we created the hash set, so that's why it starts out empty. But what we're gonna do is we're gonna start adding words, so we can start adding string objects. So what we can do is we could say unique words.add of August, right? And then we could say unique words.add of summertime, okay? And then what we wanna do is we wanna just basically be able to go ahead and figure out how we would basically look at all of the words in this set, okay? And so we can call this add method, and that would add specified elements to the set if they're not already present, because what we're doing is we're saying that sets cannot contain duplicate elements. So if a set already contains the element, then the call leaves the set unchanged. So that's what it's saying here, right? So then what you could do is you could say, you know, for each of the words in the set, so you could say for string u in unique words, right? And now it doesn't make sense to talk about index positions, right? So one of the things you need to understand is that stacks, queues, and sets do not have index positions, okay? You cannot reference them like arrays or array lists, right? We're not really talking, or, you know, or linked lists, right? We're not really talking about index positions. So what you have to do is you want to think about using an iterator or a for each loop, right? We've talked about iterators, and we said that we could create an iterator based on a stack or queue if we want to print all the elements in the stack or queue. But, or you could do a for each loop, or what you could do is you could say system.out.println of u, right? You would just want to print each of the unique words. So now if we go ahead and compile it and run this code, then we could do void main string args, and again, it's just gonna hide in the back, but it would be true hot summer, it would be hot summertime in August, right? Because the true is still getting printed because the unique words was empty, the set was empty at the beginning, but that's what we printed. But what if you said something like this? What if you said what if we tried adding an element multiple times? So we say for in v equals 0, v is less than 10, and then we say v plus equals 1, and then what if we say unique words dot add of it's hot, okay, or something like that. And then what we can do is try to see how many it's hots he would get, right? How many it's hots we would get, right? Because if we're talking about an array list or linked list, it would be okay to have duplicate elements. But with a set, the whole point of a set is that there are no duplicate elements allowed. So even though you wrote it's hot, even though you added that multiple times, it's only going to appear once, okay? And the other thing to know about a set is that sets have no ordering, okay? So even though we added it's hot after we added August and summertime, when we ran the console output, you saw that it's hot appeared before summertime and August, and that's because sets have no ordering, right? It doesn't make sense to talk about the beginning of a set or an end of a set, right? But basically, what we would do is we would just think about having only duplicate elements. So what if you said unique words dot remove of it's hot? So what if you just remove it's hot one time? Well, then it would basically disappear from the set, because sets can only have an element up to once. So if you say clear at one time, then it would be gone, right? What if you try to remove an element that does not exist in the set? So basically what the remove method says is it says it removes the specified element from the set if it's present, okay? And if it's not present, there's no error, okay? There's no exception thrown or anything like that, but basically nothing would happen. So now if you go ahead and run the main method and we go ahead and show the terminal window, we just get summertime in August, because even though we tried adding it's hot 10 times, it was only added once, and then we removed it with the remove method, and then we also tried removing February, but since February was not in the set, it didn't make a difference. So hopefully that's clear to you. And then you can also have a clear and a size, okay? And then you can also have an iterator and a remove and a contains, okay? So we probably have to talk about this in the next video, but what we could do is we could say system.out.println of what if we said unique words dot contains of August, right? And you could basically go ahead and check to see whether or not a particular element exists within the set, right? And whether or not a unique occurrence of the element exists within the set. So now if you go ahead and run the main method, this is really annoying that this keeps hiding from me, but you would get true, right? You would get true as the last thing printed on the console because that word exists in the set, right? But then if you say of October, right, and then you go ahead and run it, you go ahead and run the main method here, what we would do is we would go ahead and look on the terminal and you would get false, right? You can also have an iterator, right? So you can also have an iterator. So you could say iterator of type string, and then you could say my words or something. You could just call it anything else, but then you could say unique words dot iterator, right? So we've already talked about how an iterator can be applied to an array list or linked list, but it can also be applied to a stack and a queue and a set. And then what you would do is you would use it in the exact same way. So you would say while my words dot has next, right? And then you would basically just be referring to the elements in the string, in the set, by using the iterator, right? And then you would say system.out.println of my words dot next, right? And this is essentially how you use an iterator, right? And then what you would do is you would go ahead and run the main method, right? And then you could go ahead and see this right here. And so it would say just summertime in August, right? So you would be able to iterate through. Okay, and the last things we want to do is we want to talk about, you can also remove an element, right? But we said myWords.clear, right? And you could basically remove all elements from the set. Okay, myWords.clear. Or well, it would not be called on the iterator, it would be called on the set. So you would say unique words.clear, and then you could check to see whether or not it's empty. So you could say unique words, so unique words.isEmpty, and you could just make sure that the set has no elements in it. So now if you go ahead and compile it and run the main method, hopefully that's what you would see on the console. So from UMills03, thanks for watching and please subscribe.